In this video, we're going to cover a one sample Z interval for a proportion. Using your Forest Z method, we've got the template up here for us. What do you want to be when you grow up? According to a nationwide survey of a random sample of 1,000 kids under the age of 12, some kids want to be a ninja, a dragon keeper, a dancing unicorn, and even an octopus. 55 of the 1,000 kids want to be a doctor. We would like to use this study to find a 98% confidence interval. So we'll fill that in there. For the true proportion of all kids nationwide who want to be a doctor. There's our parameter. So part one of choose is to choose a procedure and then write down our parameter. So I have a single proportion. I have that p hat is 55 out of 1,000. Okay, my procedure, because I have a single sample, is a one sample Z interval for a proportion. My parameter is the true proportion of all kids nationwide who want to be a doctor. Check our conditions. Well, the first condition for any of our procedures is there randomness. A random sample of 1,000 kids was taken. So we can generalize. A 1,000 is less than 10% of all kids under 12 nationwide. So we can sample without replacement. And the last is large counts. And that is n times p has to be greater than or equal to 10, or n times 1 minus p must be greater than or equal to 10. So my n is 1,000, and my p, or in this case p hat, because that's all I have, is 55 over 1,000. And that equals 55, greater than or equal to 10. And then 1,000 times 1 minus 55 over 1,000 is 945 over 1,000 equals 945, which is greater than or equal to 10. It's very important that we write this value down, the 55 and then 945. Now we can make this 0.055. You can do the calculation with the decimal instead. 1,000 times 0.055 is again 55. And 1,000 times 1 minus 0.055 is 0.945, which is 945. So whether I use the fraction or the decimal, I end up with the same value. If it was rounded, they might be off by a tad, but that's okay. So we can use a normal model. Remember that the AP exams right now are graded on a 4-point scale, the questions, each question, and each of these C's is one of those points usually in the question. So it's important that we get all of the information that we're looking for written down, and we check our conditions, we write down what we're using, our procedure, and we write down our parameters. The general formula for a confidence interval is the point estimate plus or minus the margin of error. In this case, our point estimate is our p hat, plus or minus our z star. And the standard deviation, margin of error is the critical value times the standard deviation. The critical value is z star. The standard deviation is p hat 1 minus p hat over n. And so when I plug in my numbers, I get 0.055 plus or minus. Well, your z stars for 90% confidence is 1.645. For 95% confident is 1.96. For 98% confident, it's 2.326. And for 99% confident, it's 2.576. These can be found at the bottom on the infinity row of our table B, which is the table of t values. But at the bottom is all of the critical values. And these represent, on the normal model, the z-scores that represent 90% in the middle, 95% in the middle, and so on. So the exact z-score for 95% is 1.96, which in the beginning of the year we said approximately 2 standard deviations contains 95% of the data. So my z-star for 95%, or it's 98% confident in the question, right? Up here, 98% confidence. I'm going to be using 2.326. And then times the square root of 0.055 times 0.945 divided by 1,000. And then I can plug that in my calculator. And you can see what it looks like. Once I plug it in the calculator, you can see that. I'm trying to get that glare off of it. There we go. Okay. So you can see that when I plugged it in, I just typed it all in with no parentheses, and then it does the order of operation correctly for me. So I do my minus the 2.326 square root, no parentheses, I can just plug it all in. So my interval is from 0.038 to 0.0718. Okay, try to keep 3 decimals, 3 good numbers, not the leading zeros, in your answers. And then our conclusion. We say we are blank % confident. In this case, we are 98% confident. The interval from blank to blank, in this case, 0.0382 to 0.0718, captures our parameter, which if we go back to the top, our parameter is the true proportion of all kids nationwide who want to be a doctor. And we're going to put that in our context for the problem. So captures the true proportion of kids nationwide who want to be a doctor. Okay. All right, and those are your 4 C's for your confidence interval.